Welcome to The Explainer. Today, we're tackling what is, without a doubt, the most complex object in the known universe. So, let's just start with a question that sounds, well, almost impossible to answer. How do you even begin to map a universe? Especially the one that's right inside your head. Because that's really what the brain is, right? A 3-pound universe of just staggering, beautiful complexity. I mean, think about it. It's home to roughly 86 billion neurons. Each one is connected to thousands of others, and they're all firing together in this incredible symphony that creates our thoughts, our feelings, our consciousness. And the craziest part, it does all of this using less power than a dim light bulb. So seriously, how on earth do we even start to map something like that? Well, to try and make sense of it all, our first map comes from a world we're all getting pretty familiar with. Artificial intelligence. This view basically treats the brain as a kind of biological machine. Okay, so let's start with something like vision. You know, the brain's visual cortex, it processes what you see in layers. First, it spots simple edges. Then it builds those into shapes, and then finally into whole objects. Now, what's amazing is that this is strikingly similar to how convolutional neural networks, or CNNs, power computer vision. It's like nature invented deep learning millions of years before we ever did. And it's not just vision, not by a long shot. Take the brain's memory center, the hippocampus. It basically acts like a super sophisticated search index for all our experiences, right? It lets us recall things in a snap. And guess what? This is precisely the idea behind memory-augmented networks in AI, which use, you guessed it, an external memory drive to boost their performance. So, okay, here's the really crucial point. The brain isn't just a passive receiver of information. It's fundamentally a prediction machine. It is constantly, and I mean constantly, guessing what's going to happen next. And then, when it gets something wrong, it updates its internal model. You know what that sounds like? That is the absolute essence of self-supervised learning in AI. And believe me, the parallels just keep going deeper. You know that feeling of surprise or reward you get? Well, that's just dopamine signaling something called a reward prediction error, a term pulled straight out of the reinforcement learning textbook. That old saying, neurons that fire together wire together? That's basically a biological version of updating weights in a neural net. And when you sleep, your brain performs experience replay to lock in memories. All of these have direct one-to-one counterparts in the world of AI. But, and this is a huge but, this machine learning map, as powerful as it is, it has a massive blind spot. It's great at explaining the mechanics, but it tells us nothing about the magic. I mean, think about it. Machine learning can explain the function, right? The computation, the prediction, all the what. But it has absolutely nothing to say about what it feels like to be a brain. The experience of seeing the color red or hearing a violin, or just that rich, unified feeling of being alive. It can explain the machine, but it can't explain the ghost in it. So what are we missing? I mean, if the brain is really just an incredibly complex biological computer, then where does consciousness come from? Where does that seamless first-person experience of you, being you, actually emerge from? To even begin to explore that question, we need a second map. And this one is, well, it's a lot stranger. It's a map inspired not by classical computers, but by the completely bizarre, counterintuitive rules of the quantum world. Now, it's really important to get this. These two maps aren't fighting each other. They're more like complementary pieces of a much bigger puzzle. The machine learning map is fantastic for explaining the brain's algorithms, the how. But the quantum map, that gives us a language for the experiential side of things, that subjective feeling, what philosophers call qualia, of what it's like to be you. Okay, so to be clear, these are mostly analogies for now, but they are incredibly powerful ones. Think about holding two totally conflicting ideas in your head at the same time. That's kind of like quantum superposition, or how all your senses, sights, sounds, feelings, all bind together into one single, unified conscious moment. That has echoes of entanglement. And what about that sudden aha moment of insight? That feels a lot like a wave function collapse, where a whole cloud of possibilities suddenly snaps into one single clear answer. These quantum ideas give us a whole new vocabulary to talk about the things that classical computing just can't touch. So which map is the right one? Is the brain a classical machine, or is it something more? Well, the most exciting thinking right now suggests the answer isn't either or, it's both. And this is what leads us to a new, unified theory of the mind. The secret, it seems, might be that the brain is a multiscale computer. It operates on different levels, with different rules, all at the same time. So at the big macroscopic level, the level of large neural networks, it acts just like a classical machine learning system, handling all that prediction and learning we talked about. But if you zoom way, way down to the microscopic, molecular level, some theories are now proposing that quantum-like dynamics could be the very thing that generates the unified field of consciousness itself.
And this is just a beautiful synthesis because it resolves the paradox. It suggests this elegant dance between two totally different operating systems. So the brain uses classical rules to compute, to learn and predict. But it might be using quantum-like rules to cohere, to bring everything together into that single, unified, conscious I that you experience every moment.
Okay, so what does all this mean? What does this new unified map of the mind actually teach us about the future of artificial intelligence? What's the big lesson we should be taking away from this? Well, here's the takeaway. Today's AI, for all its power, is really only built on one of the brain's layers, that classical, computational one. If we ever want to create an AI that doesn't just process information, but truly understands it, one that doesn't just mimic consciousness, but actually has it, then maybe we need to build it using the same multiscale principles our own minds use. It suggests that the next great leap for AI might not just be about building bigger and bigger models, but about embracing a fundamentally new and much deeper kind of computation.